So now write a Python code to find GCD of two numbers. So this is the program to find the GCD of two numbers using recursion. Using recursion. For example, we have taken the A value equal to 62 and B value equal to 8. We want to find GCD of these two numbers A and B. So manually we will see what is the output we will get. For example, I will divide 62 with 8. 8 sevens are 56. What is the remainder value here? 6. Now divide 6 with 8. 6 ones are 6. Remainder value is 2. Now divide 6 with 2. 2 threes are 6. Remainder value equal to 0. So 2 is the GCD of given two numbers. 2 is the GCD of given two numbers 62 and 8. So this is a logic to find GCD of two numbers. We already know how to find GCD of two numbers. So now we'll see the code how it is going to be executed. To find the GCD of two numbers, what we have to do? We have to read two integer values. So here n is one integer value and m is another integer value. Suppose I have given n value equal to 62 and m value 8. Same example, suppose if I taken n equal to 62 and m equal to 8 and print GCD of two numbers equal to is GCD of n comma m. GCD of, that means there is a function called GCD of n comma m. What is the n here? 62. What is the m here? 8. So this is the function call. So the interpreter checks the GCD function and 62 will be assigned to x and 8 will be assigned to y. Whatever the function will return, that will be printed here. That will be printed here. So x gets value 62 and y gets value 8. Y gets value 8. So this is the function call. So what is the function call here? GCD of 62 comma 8. 62 comma 8. So x gets value 62, y gets value 8. Now reminder equal to 62 mod 8. 62 mod 8. What is the remainder value we got here? 6 is the remainder value. 6 is the remainder value. Now, if remainder value equal to 0, return by. But remainder value we got here 6. So 6 equal to 0, condition is false. So it comes to the else case. In else case, what is here? Return GCD of y comma remainder. Y comma remainder. So there is another function called here GCD of, what is the value of y here? 8 is the value. And what is the remainder value here? 6. So this will be returned. So whatever value you got here, that will be returned to this particular function call. So now GCD of 8 comma 6. Now GCD of 8 comma 6. So 8 will be assigned to x, 6 will be assigned to y. So x gets value 8, y gets value 6. Y gets value 6. Again, remainder equal to 8 mod 6. 8 mod 6. What is the output we'll get here? Remainder equal to 2. Remainder equal to 2 will get it here. So 2 equal to 0. Condition is false. So it comes to the else case and return. Again, whenever this is a function call, again there is a function call because function calling itself is known as recursion. The function calling itself is known as recursion because GCD function calling again GCD within itself. So again GCD of y. What is the value y here? 6. And remainder value is 2. Remainder value is 2. So GCD of 6 comma 2. So return GCD of 6 comma 2. 6 comma 2 here. So again, what will happen here? Again, x get value. So 6 will be assigned to x, 2 will be assigned to y. So x get value 6 and y gets value 2. Again, the code will be executed here. So reminder, start. So here GCD of 6 comma 2, 6 will be assigned to x, 2 will be assigned to y. So x equal to 6, y equal to 2. Again, reminder equal to x mod 2. So reminder equal to 0 will get it. Reminder will get the value 0. So whenever you got the reminder value 0, return y. So what is the value here? Y value is 2. Because here condition is true, so it won't go to else case. Simply it will return y value. So what is the y value here? 2. So for this particular function call, we got the output 2. So we got the output 2. So here what will happen? Return 2. Here what will happen? This returns 2. Again there is this is again this function call. So here return 2. Again, so where you got this GCD? By calling GCD of 6 command. So it returns value 2. So what is the output GCD of? So what is the output GCD of 2 numbers equal to 2? So you get the output is 2. So as per manually we got the output is 2. So in the program also we got the output is 2 here. So this is the logic for finding GCD of 2 numbers using recursion. Recursion. So this is the logic. Reminder we have to calculate. If reminder equal to 0, return by. Otherwise, again we have to call GCD of y comma reminder. Because here you see, first we are dividing 62 with 8. Whatever reminder value we got, that will become a x here. That will become here a equal to 62 and b equal to 8. So whenever you divide 62 with 8, what is the value we got here? 6 we got the value here. 6 we got the value here. That's why 6, whatever value you got here, that will again it is a divider, and whatever value this will become here is the divisor. So GCD of y comma reminder. This is the logic for finding GCD of 2 numbers. Now we'll see another program. Write a Python code to calculate exponent value x comma y using recursive function. Our own function we have to write by using a recursive function. So for example, to find the exponent value, we require 2 numbers. One is base value and the one is exponent value. First is the base value and the one is a exponent value. So m is a base value here, m is a exponent value. Suppose I want to find 5q. I want to find 5q. We already know how to find 5q. 5 into 5. So 5 into 5, 25 into 5 is equal to 125. We have to get the output. So we have to write a logic to find GCD of 2 numbers. To find exponent of x power y by using recursive function. So m equal to 5, m equal to 3. So this is the program for finding exponent using recursion. Here you see enter first number. Suppose I entered m value 5, m value 3. So after that, print result equal to EREC is the recursive function. So it will call EREC of 5 comma 3 because n value 5, m value 3. Suppose I given, so it will call EREC of 5 comma 3. Whenever there is a function call, the control will go to the definition of the function, and here x get value 5 comma y gets value 3. X get value 5 and y gets value 3 here, and if y equal to 0, return 1, else return x into EREC of x comma y minus 1. That means it is a recursive call again. It is a recursive call. So what will happen here? Here y value 3 equal to 0, condition is false. So it comes to the else case, and now it is going to be executed whenever there is a function call here 5 comma 3. What we are going to execute? RETURN return of x into, what is the value of x? 5 into EREC of x comma 5 comma y minus 1 2. 5 into EREC 5 comma 2. Again there is a function call here. Again there is a function call. So whenever there is a function, again it will go to the definition of function, and now x value will get 5, y value will be 3. So here when this function call, x gets value and y gets value 2. Y gets value 2. So here y equal to 0, but y got here 2. 2 equal to 0, condition is false. So again it comes to the else case. Again return of x 5 into what is the y minus 1. EREC of 5 comma y minus 1. 5 comma y minus 1, that means 1 you will get it. 1 you will get it. Again there is a function call. Again there is a function call with the new parameters. Previously 5 comma 2, now 5 comma 1. 5 comma 1. So x get value 5 and y get value 1. Y get value 1. Whenever this function call 5 comma 1, x get 5, y get 1, y get value 1. So y equal to 0. Y equal to 0, then return 1, but y is not equal to 0. So again it comes to the else case. Again there is a function return else case. What is else case here? 5 into EREC of x comma 0. 5 comma 0. 5 comma 0. So again there is a function call. Here x equal to 5 comma y equal to 0. X equal to 5 and y equal to 0. So when coming to the body of the function, x gets value 5, y gets value 0. 0 is equal to 0, condition true, so return 1. So whenever this function call returns 1 here, so what it will return? This function will return the value. This function will return the value 5 into 1, because here for this function call we got the output 1. So 5 into 1, 5 will be returned to this particular function call. So when coming to the here, 5 into, for this particular function call, what is the output he got? 5 he got here. So 5 into 5 equal to 25. 25 will be returned. So this return value will be substituted here. So for this particular return value, 5 into 25. 5 into 25, 125, that will be returned for this particular function call. So you got the output here 125 for this particular function call. 5 comma 3, whenever you call EREC of 5 comma 3, you got the output 120. So result equal to, what is the output you will get in here? Result equal to 125. Result equal to 125 we will get here. So this is the output we got here. So this is the way of calculating exponent by using recursive function. Simply what you have to do, every time we will do minus 1. Every time, here you see number is 5 only, but here how many times you want to execute? 3 times. That's a 5 comma 3, next 5 comma 2, next 5 comma 1, next 5 comma 0. Whenever there is a 0, it returns 1. So this is called a base condition, or we can call it as a terminating condition. This is called a base condition or terminating condition, because recursive function must be, there must be a terminating condition, must be exist. That's why this is the terminating condition. Whenever y gets 0, it returns 1. So that will be multiplied with 5. 5 into 5. Sorry, 5 into 1, 5. Again that will be substituted here. 5 into, for this function call you got value here 5. 5 into 5, that is 25. That will be substituted here. So 5 into 25 will get the value 125. That will be returned. That will be returned here. That's we got the output 125. So this is the program. Now next program is write a Python code to print the Fibonacci series using recursion. So what is the Fibonacci series? So Fibonacci series is nothing but we have to start with two numbers, suppose 0 and 1. Add these two numbers, we get the third number, that is 0 plus 1 is 1. Add recent two numbers, 1 plus 1, we have to get 2. 2 plus 1 is 3. 3 plus 2, 5. 5 plus 3, 8, so on. So this is the Fibonacci series can be generated by in this fashion. First we have to take two elements A and B, for example. Simply adding up A and B, you will get the value C. A and B, suppose A and B you add, you will get the value C. Now again this will become A and this will become B. Add these two, will get the next number. Next this will become A, and next result will get the value B. So A plus B, again we get the value next number. So in this fashion we have to calculate Fibonacci series. But here we have to calculate by using recursion. By using recursion we have to calculate. So we'll see how it is going to be evaluated. For this particular recursive function we have to use a for loop. We have to use a for loop. N equal to input, enter number of terms. So that means how many Fibonacci numbers you want, you have to enter. For example, I have written n equal to 5. N equal to 5. So for I in range. So how the loop will be executed for I in range of n. That means it will take the value 0 to 4 only. 0 to 4 only. You already know range function always starts with 0, ends with n minus 1. Ends with the n minus 1, that is 5 minus 1, that is 4. So in the function call, first it will call print of fib of 0. First I gets value 0. First I gets value 0. So what is the values here? 0, 1, 2, 3, 4. So first value 0 will be assigned to I. So print fib of 0. So print fib of 0. So here output will see here one by one. So fib of 0, there is a function call. Fib of 0, there is a function call with the argument 0. So when coming to the here, n gets value 0. So 0 less than 2. Yes, 0 less than 2, that's it, returns 1. So 1 will be printed because fib of function call is within the print statement. Whatever this function will return, that will be printed. So this function will returns 1 because 0 will be assigned to here, 0 less than 2 condition true, return 1. So 1 will be printed on the output screen. 1 will be printed on the output screen. So again there is function call again. So print of now fib of 1. Fib of 1 because I gets value 1. So 0 already completed, now 1. So I gets value 1. So print fib of 1. Print fib of 1. Now the argument value is 1. So fib of 1, n gets value 1. 1 is less than 2 condition true, it returns 1 again. So 1 will be printed again. So 1 we gets the output here. So again, so now gets value 2. Now gets value 2. So I gets value 2. So print fib of 2. Fib of 2. Now fib of 2 means the control will go to here. So n gets value 2. N gets value 2. 2 less than 2 condition is false. 2 less than 2 condition is false. Whenever this function call, then what will happen here? Fib of n minus 1. N value 2. 2 minus 1 means 1 plus fib of 2 minus 2. Fib of 2 minus 2 0. So this is the value we have to calculate. This is the value we have to calculate. Already fib of 1 means what is the output you got? 1. Fib of 0 means what is the output you got? 1. So 1 plus 1 will get the value 2. 1 plus 1 will get the value 2. So fib of 2 means you will get the value 2. You will get the value 2. Now next item will be assigned to I. So print fib of 3. Fib of 3. So we have to calculate fib of 3. We calculate fib of 3. N gets value 3. 3 is less than 2 condition false. Come to the else case. In else case again there is a function call, that is fib of 3 minus 1 2 plus fib of 3 minus 2, that is 1. So fib of 2, again there is a function called 2 is less than 2 condition false. Again it comes to fib of 2 minus 1 1 plus fib of 0. For this particular function call, what is the value? This is the value. Plus again this will be added here. So plus fib of 1. Fib of 1. So fib of 1 means 1 only because 1 less than 0 condition true returns 1 plus fib of 0 means 0 less than 2 condition 1 and fib of 1 is 1 less than 2 condition true returns 1. So what is the output we got here? 3. So this 3 will be for this particular function call. So fib of 3 means you got the output 3. Next function call print fib of 4. Fib of 4 because 3 already completed. Now I gets value 4. So fib of 4 means the counter will go to here, n gets value 4. Fib of 4 means n gets value 4, 4 less than 2. 4 less than 2, condition is false. So it comes to the else case. When coming to the else case, so fib of 4 minus 1, that is 3, plus fib of 4 minus 2, 2. Again there is a function called 3. 3 equal to 3 less than 2, condition false, it comes to the else case. Again fib of 3 minus 1, 2, plus fib of 3 minus 2, 1. For this particular fib of 3. For fib of 2 again fib of 2 minus 1, 1 plus fib of 0. Already this will be existing here. So fib of 1. Fib of 1. Plus, what is this fib of 2? Again, fib of 2 minus 1, that is 1 plus fib of 0. Fib of 0. These two added here. So fib of 1 plus fib of 0. Fib of 0. So fib of 1 means 1, 0 means 1, 1 means 1, 1 means 1, 0 means 0. Sorry, 0 means 1. So what is the output? 1, 2, 3, 4, 5. So you got the output 5. So fib of 4 means you got the output 5. For this particular printer, fib of 4, you got the output 5. So like this you can generate the element. So n value 5. That's why you got only 5 elements. 1, 1, 2, 3, 5. You can also start with 0 as per our requirement. So we started with 1, 1. That's why we got the output. Next element is 2. 2 plus 1 is 3. 3 plus 2, 5. So we got the Fibonacci series. Suppose I want to get here 0. Then what you have to do? Here we have to change the condition. Here we have to change the condition. Then we will get here 0. Otherwise you can start, n starts with here you have to change the condition. Then we will get the value 0. So like this is the logic for finding Fibonacci series using recursion. Thank you. Last program is write a Python code to count number of times a recursive function is called. If you want to calculate how many times the recursive function is executed, the count if you want to know, then this is the code to find number of times a recursive function is called. For example, print number of times recursive function is invoked. REC of 100. Suppose I have given REC of 3. REC of 3. So 3 will be come to n. So n gets value 3 and count equal to 0 here. Count equal to 0. Default argument, that means if you are not passing any value, count will become 0 automatically. That is default argument. So default value will be assigned. Default value equal to 0. Default value, count value equal to 0. If n equal to 0, return count, else return. Again there is a function call. So here n is 3. So 3 equal to 0, condition is false. It comes to the else case. So again it will return of REC of 3 minus 1, that is 2 comma count plus 1, count value 1. Count value 1. So again there is a function call here. So n value 2, count value 1 now. The count value 1 now. So n equal to 0, condition is false. Again it will call return of REC of n minus 1. What is the n value here? 2. So 2 minus 1 will become 1, comma, count value will become 2. Count value will become 2. Again, this is the function call. Again, this is a function call. And n value 1, count value will become 2. So n value 1 equal to 0, condition false. So it comes to the else case again. So return REC of 1 minus 1, 0. Comma 2 plus 1 is 3. That means here you see count is we are incrementing and we are decrementing the n value. We are decrementing the n value. Again there is a function called REC of 0 comma 3. So n gets value 0, count will become 3. So n equal to 0, return count. So n is here 0, that's why it returns value 3. So 3 will be returned here. So that will be returned here. That will be returned here. That will be returned here. So what is the output? REC of 3 means what is the output we got here? 3. So the number of times recursive function is invoked, you got the output is 3. Suppose I have given REC of 100. So what is the output I'll get? Number of times recursive function was invoked equal to 100. So what is the argument we are passing? That many times the recursive function is executed. So this is the program to find how many times the recursive function is invoked. Okay, thank you.